Topic 3 in your textbook, I've split into 2 sections here. So the first section we'll look at resistance. This is found on page 279 to 283 of your textbook. Resistance is a measure of how difficult it is for the electrons to move through the conductor, aka a wire. Resistance hinders the movement of charge and converts electrical energy into other forms, like heat or light. Generally, good conductors have low resistance and poor conductors have high resistance. The symbol for resistance in a mathematical equation is R. The unit of resistance is ohm. So if within our mathematical reaction or equation, my goodness, I want to think about chemistry. In our mathematical equation, if we see R, we could sub in something like 3 ohms as a value for R. Resistance is measured with an ohm meter or a multimeter. A multimeter just includes different measurement devices, so it'll include a voltmeter and ammeter as well. Resistance is like friction. It's the force that opposes the flow of electrons. The heavier the load, like a light bulb or some other sort of resistor, the more work the electrons must do, the higher the resistance for the electrons. So a 100-watt light bulb uses more energy than a 40-watt light bulb because the 100-watt light bulb will have more resistance. We can calculate this using Ohm's law. Ohm's law says the current in a circuit is dependent upon the potential difference, aka the voltage, and the resistance in the circuit. So current was I, potential difference or voltage was V, and R is resistance. So this equation is important, and we can arrange this different equation to solve for all 3 variables. So we again have V equals I times R. We can also say that I is equal to V divided by R. And we can say that R is equal to V divided by I. So you'll need to know how to use each of these equations. I'm going to choose the equation based on what I'm solving for. So what I'm solving for is the only thing on one side of an equation. And what I would have in my question would be these other 2 pieces of information. Something to note, as the voltage increases, the current must increase if resistance is staying the same. As the resistance increases, the current decreases if our voltage is the same. So let's put these into play. An electric heater has a potential difference of 120 volts and uses a current of 12 amps. What is the resistance in the circuit? So what we should do and get in the habit of is writing out what we know. A potential difference of 120 volts tells me that our voltage is 120 volts. So I write the symbol that what I would find in our mathematical equation and then what the value for that was. It also has a current of 12 amps. Current is represented by the symbol I, and that is 12 amps. What we are looking for in this question is the resistance. So I'm going to give that a question mark. Using our formulas from the previous page, I know that I need to select the formula that has something that says R equals, because R is what I'm solving for. We know that R is equal to voltage over current. Once I've written out my formula, now I'm going to sub into my formula. So I'm going to say that R is equal to V, which was 120 volts, divided by I, which was 12 amps. 120 divided by 12 is 10. And remember, the unit for resistance is an ohm. So 10 ohms is my final answer. A radio uses a 6-volt battery. Now, it doesn't tell us exactly what this is, but the unit of volts should tell us that this is potential difference or voltage. So we are saying that that is V. And it has a resistance of 3 ohms. So R equals 3 ohms. What is the current? Current is I. So we're going to use the formula I is equal to V over R because I am solving for I and I is on its own in this formula. So that equals, if it's V over R, that equals 6 volts over 3 ohms. 6 divided by 3 is 2, and the unit for current is amps. Let's try another one. A circuit uses a current of 4 amps. So current is I. That gives us 4 amps. And a resistance of 30 ohms. R equals 30. We are looking for the potential difference or voltage. Therefore, we need to use our original form of our equation. V is equal to I times R. Therefore, we know that V is equal to 4 amps times 30 ohms. A good habit to get into is including our units in our equation. When I write a number, I need to say that it had a unit. It is not just a unitless quantity. Okay, so I write my units within my equation. All right, 4 times 30 is 120. And the unit of voltage is volts, V. So the potential difference is 120 volts as my final answer. Ohm's law is based on the following principles. The potential difference or voltage is not affected by either current or resistance. It is something that is given. Current is affected by either the potential difference or the resistance. If the voltage is high and the resistance is low, we have a high current. Let's use this little image here to describe that. I cannot control the volts by current or resistance. Voltage is simply the push that exists. So, if the push that exists is high and the resistance is low, so this is a low squeeze, this guy can move through quite easily. Therefore, our current is high. If the potential difference is low, so the push is weak, and the resistance is high, we've squeezed quite a bit, it takes a lot for the current to get through. Resistance is not affected by current or voltage. Resistance is its own beast and controls itself. Okay, resistance is there based on what type of wire we're using, what type of load is included in our circuit, etc. Resistors. The major application for resistors is to control the current or voltage to suit the specific needs of other things within the same circuit. So if we want something to have a lower current than what is provided, we may use a resistor to limit the current beyond that point. So if we have a high current, we might put a resistor in place to lower the current for something else using that electrical current later on. There's different types of resistors, and the different colored stripes on a resistor indicate the level of resistance they provide. So whether they have a tight squeeze or just a little bit of a squeeze on that current. There's also something called a variable resistor. So typically a regular resistor just strictly limits, it has no variation, it is set. A variable resistor is used to change the resistance in a circuit. It's not fixed. So for instance, the volume control within your TV or a radio has a variable resistor to change that current to change the volume. Same with a dimmer switch within our light systems or a temperature control on our stove or a heater. So there's 3 different types of variable resistors: a rheostat, which is a dimmer, a thermistor, which is heat resistive, or a varistor, which is like a surge protector. This image is straight out of your textbook if you want to take a look at it there. It has a little bit of an explanation as well. So these are the 3 types of variable resistors that we're going to talk about. And here is their symbol. Okay, so add those to your list of symbols that we'd had from earlier. A rheostat have a slide-shaped armature that controls the total resistance. So these are able to move here. They're usually found in high-power electric circuits, such as power distribution equipment. A thermistor is sensitive to changes in temperature. Thermistors are used in thermostats and little heat sinks. Okay. Last one, a varistor. They are voltage-dependent resistors used in a circuit to protect it from high voltage surges. Resistance in wire. So even copper wire, which is very conductive, has resistance. Things to note is that thicker wire has a lower resistance per length than a thinner wire. So if we look at a power cable here, a power cable is surrounded by a rubber insulator on the outside so that electricity is not conducted to anything we are able to touch. Inside, there are copper wires, and these are insulated by paper around them so that they aren't touching one another. This is because we have a positive, negative, and a ground within our wiring. Okay, power cables are made of many thin copper strands which act together like one large diameter conductor. This reduces resistance and heating and makes the cable more flexible. A few different factors affecting resistance. The length of our cable. Resistance increases with length. So if we double the length of a wire, we double the resistance in that wire. The cross-sectional area, aka the thickness. Resistance decreases with an increase in area. We just saw that thicker wire has a lower resistance. So if the cross-sectional area of a wire doubles, again, that's this area doubles, the resistance is halved. Again, as the thickness increases, resistance decreases. Temperature. As the temperature of a wire increases, resistance also increases. Material. Some materials allow electrons to move more freely than others. So a better conductor is really what we're looking at here. Practice for this topic, don't forget to take a look at that learning guide, and then there's some extra practice within your textbook if you're looking for it.